So in this part we're going to find out how to write the electron arrangement, electron configuration for some ions, for some typical ions. And first let's look at some cations. So we're going to look at the element, first of all, iron, and then it's two ions, it's Fe2 plus and Fe3 plus. So first of all, where is it in the periodic table? So we can see that iron is here in the D6 group, and it's in the 1, 2, 3, 4th energy level, but remember for the D block we need to take 4 from 1, so it's in the 3rd row. And therefore we know that iron is going to end up with the electron configuration 4s2 3d6. That is the iron atom. Now we also know if we move backwards that it's got the argon core. It's isoelectronic with argon. So when it becomes 2 plus ions, it's going to lose electrons. And if you cast your mind back, when electrons are filling up the energy levels, whilst they're vacant, electrons fill the 4s because they're lower. However, as those energy levels are filled, the 4s moves further away and becomes of a higher energy level. So it's probably more convenient, and it actually looks better, to write the electron arrangement for iron as 3d6 4s2. And the reason why we do this is we can see that the 4s electrons are slightly of a higher energy level and they're shielded by the 3d, and it's likely they are lost more readily. So it's the 4s electrons which go first. So if we're forming a +2 ion, it means we are losing 2 positive charges, and therefore it follows that the Fe2 plus ion has an electron arrangement of Ar 3d6, but it loses these 4s electrons. And therefore it follows that the Fe3 plus ion must have lost 3 electrons. So Fe3 plus is going to lose 1 more, but this time it's going to come out from the 3d. So it's going to be Ar 3d5. And if we to visualize those electrons in boxes, here are the d electrons, and remember there are 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So this is iron, and this is the 3d subshell, this is the 4s. The electrons that are going to go first from the transition elements are always the 4s, they will go first. So Fe2 plus is 3d6, but the electron that's likely to be lost when it becomes Fe3 plus is one of these paired electrons here, forming an Fe3 plus ion. Let's have a look at some anions. So now we're going to find the electron arrangement of an ion, and this is the sulfide ion. So first of all, let's find sulfur in the periodic table. So here is sulfur, and we can see that sulfur is in the P4 group, and it's in the 3rd energy level. So we know that the sulfur atom is going to end in 3p4. The nearest noble gas to sulfur, if we move all the way back, is neon. So put that in square brackets, and neon's got 10 electrons, so it's going to be neon, and we need to get to 16, and therefore that must be 3s2. Now the sulfide ion means it's gained 2 electrons, so it's likely, if we look at the p subshell, the 3p subshell, that the 4 electrons have filled up singly before doubling up. So it's highly likely that the incoming 2 electrons are going to fill these 2 partially vacant orbitals here to become S2 minus. And therefore the electron configuration of S2 minus, the sulfide ion, is Ne 3s2 3p6. But now sulfur has become isoelectronic with argon. So we can now say that has the same electron configuration as argon. We say it is iso, meaning the same, electronic. It has the same electron configuration as that of a noble gas.